we're going to start off with prepping ourselves of understanding what would you make u. Okay, so consider the function y equals 1 over x plus 1. Could we find the derivative of this function? Yes, we could use the quotient rule. I'm not saying that yet. I don't need you to freak out yet. Then we're going to start off with some baby examples here, okay? So could you find the derivative of this? Yes, but what makes this not as easy is that it's not just x in the denominator, it's x plus 1 in the denominator. So instead of it just being an x, it's x plus 1. That would make us have to use the quotient rule. We don't want that, so what could we do? Well, you see right there with the x plus 1, we could make that equal to u. So we could make u equal to x plus 1. And then y would look like 1 over u. Or you could look at it as u to the negative 1, right? Okay. So what's the idea? We could now differentiate y with respect to u and u with respect to x, and then just multiply those two things together. Let's try again. How about finding the derivative of y equals sine of x? If y equals sine of x, or sorry, sine of 2x is what I should be saying. If it were sine of x, we would know the derivative of it. The derivative of sine of x is cosine of x. But it's sine of 2x. So the second it's not just an x in there, we start having some issues. So what are we going to have to make u? Whatever that quote-unquote inside function is. In this case, we're going to make u equal to 2x. And so if u is 2x and you rewrote y, y would equal sine of u. So we could find the derivative of that. Again, the derivative of sine of u would be cosine of u. Okay? All right, let's keep on going. We're just practicing what would you make u for this u substitution. So we have y equals the square root of 3x squared minus x plus 1. Well, if it's the square root of x, we know what to do, but since it's the square root of other stuff, we have to make all that stuff u. So u in this case would be u would be 3x squared minus x plus 1. And then y, when we substitute in for u, would be the same thing as the square root of u, or if we were taking the derivative, we would really want to see that as u to the 1/2, right? Okay. Let's do the last one here. How about tangent squared of x? Tangent squared of x, well, it may help you to think of this really. Technically, tangent squared of x is tangent of x squared. Well, we know the derivative of x squared, but we don't know the derivative of tangent of x squared. So when you look at it like this, tangent of x is really the inside function, right? So our u here would be tangent of x. And if we replace tangent of x with u, instead of y being tangent of x squared, it would be u squared. Then we could find the derivative of u squared. That would be 2u, right? Okay, so it says, find the derivative dy dx for the function y equals x squared plus 1 quantity cubed. Again, what you could do here is you could FOIL this out, do x squared plus 1 times x squared plus 1 times x squared plus 1, FOIL it out, and find the derivative individually, but that's a complete waste of time. This is a u substitution problem. So what's the idea? We want to look at the inside of the function, which is x squared plus 1. If that was just an x, we would be good to go. So here's what we're going to do. We're going to let, if I could get a pen, we're going to let u equal x squared plus 1. Okay? And then what I want you to do is I want you to take the derivative with respect to x of both sides of this equation. If they're both equal, then their derivatives have to be equal. Hopefully you agree with that. So on the left, we have du dx. And on the right, what's the derivative of x squared plus 1? Well, the derivative of x squared plus 1 is simply 2x. Okay? So we're going to keep this. We need to know what du dx is. Now I want to look at rewriting y in terms of u. So y was equal to x squared plus 1 quantity cubed, but now x squared plus 1 is u, right? That's what u is. Let me highlight that. That's what u is. So now this is going to turn into a u cubed. So that's what it is instead, is y is u cubed. So what do? Now we're going to find the derivative. with respect to u of y. So this is the derivative with respect to u of u cubed. Take the derivative with respect to u of both sides. Well, on the left we have dy du, and on the right, the derivative with respect to u of u cubed is 3u squared. So, what do we have by the chain rule? The chain rule says dy dx equals dy du times du dx. Okay? So what do we have? We'll take a look here. We have dy du and we have du dx. So this means the derivative has to equal dy du, which was 3u squared, times du dx, which is 2x. So what's wrong with that? The only thing that's wrong with that is we can't have a final answer that has u's in it. We need to back substitute. So this would be 3 times, well, what was u? U was x squared plus 1, quantity squared, times 2x. So that's what our derivative would be. Or sorry, that's not simplified. 3 times 2x, so what would that be? 6x times x squared plus 1, quantity squared. Make sure you don't try to distribute that 6x into those terms because this is a quantity squared. Anytime that parentheses is to a power more than 1, you can never just distribute directly. Okay, so that would be our final answer there. A 6x times x squared plus 1 quantity squared. Let me put that in the answer blank. Okay, so I want to revisit this problem. This is the formal definition of u substitution. This is the formal definition of u substitution. This is using the dy du, du dx, substitute, and everything. Okay, I'm going to redo this problem a second time. And I'm going to do it a little simpler for you. So, what's the idea? Let me show you the idea of what's going to happen. When you have y equals x squared plus 1 quantity cubed, and you want to take the derivative of it, what you do is you take the derivative of it just like it were x cubed. Okay? So if it were x cubed, you would say it's 3 times that amount squared. Hopefully you agree with that. That's the power rule. Drop the 3 and whatever it is. So what's the idea is you take the derivative of the outside and keep the inside exactly the same. So that'd be 3 times x squared plus 1 quantity squared. Derivative of the outside, keep the inside the same. But you always have to remember to multiply by the derivative of the inside. Well, what's the derivative of x squared plus 1? X squared plus 1 is the inside. The derivative of x squared plus 1 is 2x. And that would tell me 3 times 2x would be 6x times x squared plus 1 quantity squared. So when you get good with the chain rule, you don't even need the u substitution. You use the fact that you know that dy du is the derivative of the outside. That was the 3, keep the inside exactly the same, to this 2. That's the derivative of the outside. And then the du dx is the derivative of the inside, which was 2x in this case. Okay? So you can use the formal definition with the u substitutions, or you can take a little bit of time, learn it, get better with it, and I'm okay with you showing the shorthand notation for solving it. So let's go back to the previous page and actually answer the question that I posed for you. So the question was, what's the derivative with respect to x of 2x plus 1 to the 45th? Again, let's use u substitution the first time to make sure you understand it. The idea is, the issue is we have something raised to the 45th, not just x. So whatever that is, you let that be u. So u is 2x plus 1. Okay? So then what would u prime be? I'm going to call it u prime instead of du dx. That would be, well, the derivative of 2x plus 1 is quite simply 2. 2 times 1 plus 0, right? 2. All right? So this is the derivative with respect to x of now u to the 45th, which would be 45u to the 44th, but then you have to remember to multiply it times u prime. So anytime your variables do not match, here's an x and here's a u. Anytime your variables do not match, you need to put the u prime there. In this case, the u prime there, okay? And so in this case, it would be equal to 45. What was u? U was 2x plus 1 raised to the 44th times u prime, which was a 2. Well, 45 times 2 would be what, 90? So this is 90 times 2x plus 1 to the 44th. And there's our final answer, and we're done. Okay. So really, I've honestly shown 3 different ways of doing the chain rule. I showed the formal way of doing the chain rule with du, dx, dy, du, multiplying the two of them together and back substituting. I showed a more informal way of doing it, calling it u prime, and then taking the derivative with respect to x of u to a power, just tacking on the u prime, the derivative of the inside, never forget the derivative of the inside, back substituting, and I was done. And then I showed the even less, more lazy version where I didn't even use u's whatsoever. I just dropped the power, kept the same thing to the power minus 1 times the derivative of the inside. And again, this works perfectly fine doing that exact same thing. So if I was finding the derivative with respect to x of 2x plus 1 to the 45th power, what do? Drop the power, keep the inside exactly the same, power minus 1, but then you have to remember to multiply times the derivative of the inside. I use this horrible notation where I just put it in parentheses and I put a prime. That's because I'm too lazy to write the derivative with respect to x every single time, so I just put the prime there. All right. And again, the derivative of 2x plus 1 prime is just a 2. And then you just simplify. 45 times 2 is 90 times 2x plus 1 to the 44th. Same exact answer. Drop the power, inside exactly the same, power minus 1. Always remember to multiply times the derivative of the inside.